I'm Yesiling. Here I'm going to show you the solution of question 1 in homework 6. Question 1 provided us xy's joint density function. And the question 1 asked us to find out the A that so that above defined is a joint valid density function. According to the definition, that is the integral from infinity to from minus infinity to infinity of the little fxy dy dx will equals 1. And easily we calculated it, we can got the final answer, that is A equals 4. Question 2 in question 1 asks us to find out are x, y are uncorrelated or not. When we said x, y is uncorrelated, that is the covariance of x, y equals 0. That is exy equals ex multiply ey. So at first we calculate the ey. It will equals minus infinity to infinity and xy multiply fxy dy dx dy, and we know that x is from minus 1 to 1 and y also from minus 1 to 1, and so we calculate this expression. We got the answer is exy equals 1 divided by 9. Then we also need to find out the ex and the ey. So we calculate little fx. Little fx will equals minus 1 to 1, the integral from minus 1 to 1, and the fxy dy. And we calculated them. We got little fx equals 0.5, and your ex will equals little fx, and your ex will equals x multiply fx from the integral from minus 1 to 1 dx. Easily we can get ex equals 0, so that obviously ex multiply ey will equal 0 and will not equals exy. So we got the answer is that xy are uncorrelated, and we can also get xy are not independent. Now we solve the problem 2 and 3. Now let's come to question 4. At first we should get the expression of little fy and move on to the question. It provided us z equals x squared and w also equals y squared. It asked us to find out the joint density function. So we use the Jacobian. We can get j will equals 4 multiply 4xy. It have 4 roots. So for each have 4 roots, we can get the expression of f joint density function of f, z, and w, and that is fxy square root of z square root of w, and pass fxy minus square root of z and the square root of w and yes, just like this format, each have 4 roots. And when we got the expression calculated each, we can get the joint density function of w and y, that is the 1 divided by 4 multiply square root of z and square root of w. At last, question 5 asks us to find out whether the z and w are independent. So we can calculate the little PDF of z, and so we can find that fz will equals 1 divided by 2 multiply square root of z, and w will also equals 1 divided by 2 multiply square root of w. Compare these 3 expressions, we can easily find that the joint density function of z and w will equals fz multiply fw. So we can get that x squared and y squared are independent. And this is all the solution about question 1.